I'm going to be solving the PortSwigger lab username enumeration via account lock. This lab is from section 2, Authentication, Vulnerabilities in Password-Based Login. So with this lab, we're given a list of 100 usernames and passwords. So I'm just going to take a moment to grab the contents of these files. And the idea here is that we're going to enumerate our user by locking out their account with too many password attempts. I'm going to enable my burp proxy. And I'm just going to send a login request through it just to see how this looks. Username test, password test. Then I'll switch over to burp, take a look at the post request, and we can see that this is just pretty straightforward. It's just passing along some username and password data. So now if you have the pro version of burp, you can just set this attack up with intruder. I have the community edition, which won't be able to handle all the requests. So instead, I'm going to use a bash script with curl. I'll make the same post request with curl, and then I'll start piecing together the script. So I'm going to run my command. And as we can see from the output, we get the same response as we did from the browser. We get a response that says invalid username or password. Now I'm going to add a few extra options to the command. So I'm using the -s option for silent mode. This will run curl without displaying the progress bar. I'm going to use -o to dev.null, so any of the contents of the request gets redirected. And then I'm going to use the -w option, which is actually a really handy feature that allows you to write out variables. It's definitely worth reading about this in the manual. But the variable that I'm going to be using is size download to get the length of the page. So I'm going to run this request. And as we can see from the response, all we get is the length of the page, its bytes value, 3122. We have our command working the way we want it to. So now we're going to try to lock out one of the users. If we do that correctly, one of the response lengths will be an anomaly, and we can use that to determine the valid user account. This is where we're going to use our usernames file from earlier, and this is the script that I will be using. So what this does is for every username in the usernames file, we're going to make 10 logon attempts with that user. We're hoping that this should be enough failed attempts to lock out one of the users. If not, I'll just increase the number of requests. And when I run this, it's going to print out the user and the response length. So let's test this out. And I'm going to terminate that. So instead of just letting this run, I'm going to redirect the output to a file. It might take a little bit of time. And then I'm just going to filter the file and see if we find a response that is anomalous. So we can just use grep to filter any matches that don't have the value 3122. So when I run this, we get our user, FTP. So now that we have our username, we can use our passwords file from earlier, and we can just brute force the login. And to do this, I'm just going to modify the script that I used previously, just slightly, so we can use the password file. So now when I run this, it's going to read the lines from the password file, and it's going to make post requests with our FTP user. So we'll run that to give it a try. And now it just prints the output of the password and the response length. So I'm going to run this, same as before, redirect the output to a file, let this run, and then we can filter the file afterwards to see what the valid password is. So my script finished running, and now I'm going to filter the output. This time when I filter it, there are a few different response lengths. And that's because after too many failed attempts, the application prints out a message about this. It tells you that you've made too many incorrect login attempts rather than saying invalid password. But the value that stands out here is this value 123QWE. So I'm going to try to log in with this value as our password. So So our credentials worked and we were able to solve the lab. So that's it for now, and thank you for watching the video.